It's fantastic to be here with you all. And we're going to be talking, as Rachel said, about building reactive applications and hopefully giving you a bit more information and background as to what building resilient and asynchronous and reactive applications is really like. So my name is Grace Jansen, and I'm a developer advocate from IBM in the UK, if you couldn't tell from my accent or the lack of daylight over here. But yeah, I work mostly around advocating reactive technologies within the JVM and the Java ecosystem. And I'm here with Mary.
So I'm Mary Grygleski. I'm a senior developer advocate at IBM for the Java and open source and cloud technology space. So by night, I'm actually a community organizer. I'm also the president of the Chicago Java Users Group, as well as a few other IBM-sponsored meetup groups as well. So I'm like a really passionate developers and really like to do outreach with developers. So thanks, Grace, for the introduction. So, and I guess we'll move on to the next slide too. And so here we're talking about reactive technology. As we are kind of trying to understand why is it like becoming more important? Because if you look into it, the whole industry is evolving real fast. And right now, even the infrastructure side is also like evolving really fast. And hardware has improved, virtualization, containers, and all these technology. Right now, we're dealing with multi-core machines, multi-CPU. So the software itself would need to be catching up with what's available on the hardware side. So that's kind of pushing reactive technology to go forward. And here too, as you can see, application architecture also will need to be get adjusted because it needs to kind of take advantage of this multi-core, multi-CPU type of scenario, parallelism, containers, clusters, all these things. So reactive technology is a way to respond to these changes on the hardware, on the firmware virtualization space. Okay, so, I think I may have advanced a little. Okay, thanks. So here, now how do we evolve from our applications to take advantage of this? We'll have Grace explain that for us.
So this is where we really go into sort of how reactive systems can take advantage of this ever-evolving infrastructure. And as Mary was saying, these changes that we're seeing to both application architecture and the underlying hardware and tech underneath it. So reactive systems generally are based around this thing, around the characteristics described in the Reactive Manifesto. Now, the manifesto was created back in 2013 by a group of individuals who essentially wanted to map out the behaviors that they thought should be seen or should be sort of designed into applications to really make them non-blocking and asynchronous and highly responsive. So at the bottom here, we've got this core underlying behavior, and that's having this asynchronous message-driven backbone in our applications. By having this backbone and this asynchronous nature to it, we can really decouple the components of our application so that if one potentially fails, it won't cascade and cause the entire system to sort of collapse and complete failure. So this asynchronous message backbone is really important, and that's why it's the underlying characteristic within reactive systems. Now, this asynchronous message-driven backbone enables us to have further characteristics of the reactive systems. So, for example, on the left here, we've got elasticity. Now, elasticity really refers to being able to scale both up and down resources and components within our application so that we can deal gracefully with load changes to our system. If you take a look at, there's loads of different graphs online, but you can see the peak changes depending on the hour, the day, the time. For example, Black Friday, if you look at the traffic spikes on Black Friday, applications get huge fluctuations in the load on their systems, and we need to be able to gracefully deal with that so that we can still provide a responsive and reactive application, despite the fact that we might have loads of users trying to use our system at any one time, or maybe only a few. So that's why it's really important to have this inbuilt elasticity so we can deal with those load changes. And then we've got resiliency here on the right. Now, resiliency is all about building in sort of resilient features into our application so that we can gracefully deal with failures. Now, as much as we might try, as application developers, we can never predict every potential failure our application might come up against. So that's why it's really important to inbuild this resiliency into our applications. So if a component does go down, or if a microservice does fail or become unresponsive in some way, then we can gracefully deal with that in a way that doesn't bring the entire application down, and in a way where we're able to sort of bring that service back up by itself. And all of these three characteristics really lead to a responsive behavior. So being able to have our applications respond as soon as possible to events, to messages, to state changes. So really having this super responsive, super reactive application architecture. So how do we actually build in these characteristics into our applications? Because that's pretty high level. How do we actually go about coding it? So we need to think about the different layers of our application and how to apply reactivity into each layer. So here we've got a very basic microservice. We've just got 3 microservices, but this is just to give you an idea. So the first layer is within those microservices themselves. So within our microservices, we need to make sure that the logic within it is asynchronous and non-blocking. So we can do that by implementing things called reactive programming patterns. So what do I mean by reactive programming? Well, here's a basic definition of reactive programming. But the important part is it's all about introducing this asynchronicity into your programming logic. So it's about driving forward the logic via the availability of new information instead of just by a thread of execution. And you can enable this by introducing things like futures. So if you're a Java programmer, you're probably familiar with the concept of futures, which is essentially a promise to hold the result of the operation until it completes. You can introduce things like reactive programming libraries, for example, RxJava or Small Mutiny. Or you can take a look at the Reactive Streams specification, which Mira will be going into more detail about a bit later in this presentation. So as well as the microservice level, we also have to think about the system level. So we have to think about how do our components interact with each other or interact with third-party components. So how does microservice 2 communicate with microservice 3? Is it asynchronous? Is it non-blocking? And for this, we have reactive architecture patterns. Now, this isn't a comprehensive list of every architectural pattern for reactive because we'd be here all day. So we've just chosen 4 of the most commonly used ones for you to take a look at. So on the left-hand side here, we have CQRS. Now, CQRS stands for Command Query Responsibility Segregation. And what that really boils down to is separating out the read and the write API. And this enables really high availability of the data within it. Then we have things like event sourcing. So for those familiar with Kafka, Kafka is a tool that can be used for event sourcing. We've got Backpressure, which Backpressure is a really important component of reactive architecture and reactive systems, because what it enables is it enables feedback from the downstream components back to the upstream components to help stop components coming into a lot of load or potentially failing because they're stuck in some process and they're being overwhelmed with requests. So this feedback is a really important mechanism, a flow mechanism for them to provide feedback back to the upstream components, which normally wouldn't be possible. And then we've got things like circuit breaking. So circuit breaking, if you're familiar with electronics, for example, pretty much the same principle. So circuit breaking is all about, again, preventing components from becoming overwhelmed or overloaded. And by doing it, it basically enables circuit breaking to do that. So when a component's under extreme stress or load, they can recognize certain failure messages or the repeat of the same failure message. And what it does is it temporarily stops requests coming to that component. And instead, it reroutes them to replica services or alternative components. And so what that does is it gives that component that's under stress or load time to recover and time to get better. Once it's better, once it's recovered and can sort of perform at its full rate again, the requests are then sent back and the circuit breaking is stopped. So as I said, these are just 4 of the implementations that are available. We thought we'd include a funny GIF, but the GIF isn't working. But essentially, Backpressure, as I mentioned, is one of the most important components, and it's one that usually comes as standard with a lot of the reactive frameworks, which Mary will talk about in a bit later. But without Backpressure, sometimes your microservices can feel a bit like this, a bit like water continuously coming into your face and not being able to deal with it. So implementing these reactive design principles is all about stopping this feeling of chaos and panic, and hopefully bringing to your applications a sense of being able to gracefully handle anything thrown their way. So now let's take a look at reactive frameworks, what reactive frameworks are available for you to use, and toolkits available for you as well.
Sure. So yes, so let's start by talking a bit about reactive streams, what Grace just brought it up. Now, reactive streams is essentially an initiative that provides a standard for asynchronous stream processing with non-blocking backpressure. So you might be thinking, well, what is kind of such like long definition? But anyway, this actually is a specification, and as such is being like led by the Reactive Foundation, which is a part of the Linux Foundation now. So there are a few companies that come together and decide that, well, we need to kind of standardize this interface. And as such, too, there are no implementations to these four fundamental, like different interfaces. So you can take a look over here. These are the links if you're interested in understanding it more. Essentially, too, let's take a look. So over here, too, like a small diagram also explained to you. Basically, you can have streams of data flowing. If it's simple enough, one kind of streams it, it's okay. But in general, in today's world, we're dealing with a lot of like big data that we're collecting maybe from an IoT app or something. So you can kind of tell, data can come through like so fast that basically you can't handle it, the consuming side. So there's the backpressure that build up. So again, this specification is kind of handling how defines like how, implementation libraries should should handle this. So essentially, there are like four basic Java interfaces in here, which I've listed out in here. So there's publisher. So basically that, publisher will actually have a method to subscribe to the publisher. So whoever is interested, the subscriber, also known as like consumer in some of the messaging library and patterns. And so you're consuming. So there are like methods just such as like on subscribe, then you act accordingly on next, on error, and on completed. Then there's also the subscription. Essentially, subscription is more abstract. It deals with like the subscriber and a publisher kind of relationship in there. And that's where the backpressure support will happen on here. Because the subscription essentially will have the request, and also you can also cancel the subscription as well. Then there's also the processor part that basically you can see it extends the subscriber and the publisher interfaces too. So again, there are no APIs that actually kind of mandated for any, well, I should say the interfaces, they are just interface. There are no implementations. However, whoever, vendors want to implement it, then they have to make sure they pass the TCK, which is the technology compatibility kit, that one. So. And so just a note too about reactive streams is that it is intended for like service provider interface. So in general, we may not want to write it because it gets quite complicated if you're dealing with streams on that level. So quick thing, and let's get into another implementation of the reactive streams from the Reactive Foundation. I just want to point out is the RSocket. That's a reactive socket. It's a relatively like new library that came out since a year or so ago, and version 1.0 just happened this year in May. So this one is actually, think of like WebSocket, but this one is reactive socket. So there are four models of data that you can deal with all the streams. And so it's highly efficient too. So I'd like to suggest you to take a look into it. If you're having issue right now with your web programming, you're trying to deal with socket. So you can take a look into that. And these are on the left side, there are like 6 companies that actually form this foundation. Okay, and okay, so now let's take a look into like, getting down, earlier, Grace talked about more higher level architecture patterns, all that. So let's kind of bring it a bit, level down to programming. You also may be wondering, assuming that you are programmers, so how do you write reactive programming? So first and foremost, the reactive extension, there's an RX Java, and reactive extension came out of Microsoft from the .NET side first. Then Netflix ported it to Java back in 2013. So here is an example. So when we deal with reactive programming, we're handling streams of data. So there's actually a very good site called rxmarbles.com if you haven't already seen it. And this is just an example taken from there. So we're dealing with data traveling, on streams. So over here, and in Java, we are actually heavily relying on the functional programming model to kind of enable the reactive programming. And in fact, all of reactive programming will be utilizing this functional style of programming. And also it kind of takes advantage too of when Java 8 came out with streams, with lambdas, and that's what it's kind of becoming more kind kind of effective, for that for RxJava. So anyway, so just a quick thing showing you in here is that we're making use of an observable .just, so you kind of get the input data in, then you immediately transform it. This example using a operator called map that transforms your data. So think of it like math. You pass in a function, so it multiplied by 10. And then whoever is interested in it, the subscriber, will consume what's coming out of it. So then you can actually see, like over here on the right side, then the map will essentially transform your data like that. So yeah, so this is kind of in a nutshell how you handle reactive programming. So and here too, let me also then point out a few like more popular reactive frameworks and toolkits and libraries. So you can see here is Vert.x, which is an Eclipse project, and Microprofile, also an Eclipse project. And Akka came out of Lightband, the company that invented by Professor Martin Odersky Scala. And so Akka is also a very powerful reactive library. And in it too, there's Lagom, which is a opinionated microservices platform that's built on top of Akka. And also like here with Play. Play is actually more a front-end library, web library that also it's basically built on top of Akka. And then there's also, of course, there's also Spring Reactor. Then it comes out with the Project Reactor, a Spring WebFlux, which I'll talk about a bit in detail in a minute. But first of all, let's take a look. So IBM too, we are very much into open source, and we participate in the microprofile specification as well as contribute to the source code. So we'd like to bring this to your attention too, because it implements also the reactive streams. And if you take a look into it, microprofile is essentially a library that's catered more for like Java EE application, and also for the microservices architecture. So that's something that is really strong in. And as you can see in here too, it has all of these layers of all the different Java specs that it supports. And then there are also reactive streams, operators, reactive messaging, and GraphQL too. Those are like individual standalone projects that it also supports too. So. And over here, a quick explanation in here indicating how you can utilize reactive messaging inside microprofile is essentially make use of the annotation. So the annotated methods are basically connected by name channels, and that's how the messages get passed like in between different methods, how they travel down. So, okay, and then let's also quickly go over the Project Reactor, Spring WebFlux. So as such, it comes out from Pivotal. And Spring WebFlux itself is a non-blocking reactive web framework that supports reactive streams backpressure. So if you are actually already doing Spring project, I think that would be kind of if you want to add in like reactive capability, that would be more like a natural kind of progression if you want to do that. Then it's actually the library part is actually being handled by the Project Reactor. So that's kind of like supports the Spring WebFlux side. Yeah. So essentially too, that kind of helps, with to avoid like drawbacks of traditional asynchronous approach, then you kind of avoid the callback hell in there. So, and here just some diagrams that I think will be useful to explain a bit too about how do you stream to database. In this case, you're doing a read using reactive streams with Spring. And this is actually taken, if you're interested, is taken from the Circlet and reactive stacks in Spring framework by Rose and Steinhoff too. So you can also take a look into it. You can see too, basically in Spring, there's this concept of flux that actually handles like multiple streams. So as you can see how they travel and down into your pipeline like that. And likewise, on the right side, then you can see that the JSON stream is kind of going down, the opposite direction. So. Okay, now let's then take a quick look then at Akka. Akka comes out of Lightband. It makes use, it leverages on a model called Actor model. So Actor, basically the quick nutshell about Akka is that you never have to deal with threats directly, and even none of these libraries will need to deal with threats. But Akka, they make use of this Actor model, so then you can have two actors. They always require two actors. It's like you like talking. Think of your telephone conversation. You pick up, you're talking. You always have like a sender and receiver, and they change the roles in between. So in order to store the messages, it makes use of the mailbox concept, and it supports reactive streams. But Akka streams is kind of interesting. They decouple from the Reactive Streams interfaces, and they kind of wrap their call inside it. So it's kind of a very interesting way of how they do it too. And it supports like microservices using like Logom, and also the integration is an Alpaca connector. So, and as you can see, the diagram explains about the messaging between the different actors and the mailboxes. Okay, now then let's get to Eclipse Vert.x, and I'm actually going to be showing some code too. So over here, I won't explain in this too much, but let me share my screen quickly, and I can quickly show you some coding. Okay, FYI, if you're interested too, I'm also doing a weekly coding stream on IBM Developer on Twitch. So if you're interested in getting into more of the details, I would suggest and kind of invite you to join that Twitch stream. But let's kind of quickly take a look. Why Vert.x, right? I'm kind of excited about it. I picked this is because it's open source, it's an Eclipse project, and our Red Hat brothers and sisters over there are working on this project, and it's a synchronous engine that actually powers Quarkus. If you have been like interested in Quarkus too, and this would be the library to use. And it also makes use of like small RAI, for example, Mutiny that Grace mentioned earlier too. It's very lightweight, highly flexible, it's got a polyglot nature, very interoperable. And opportunities are unlimited. You can think of new ways. So I wanted to bring this up like examples of some use cases. You can write TCP clients and servers, and you can basically, the one thing I think people will find it really useful is some kind of like timer that you need to do, based on like events, because Vert.x has a very, I won't go into all this detail in here, but let me take a look. It has actually, these are like some of the events. Timer has fired, data has arrived on the socket. So it's a really good use of Vert.x. And it makes use of a model called vertical, similar to the ACA actor model. So without further ado, let me kind of take a look and show it to you. So now, again, the vertical model is not a must, but usually we do want to implement or extend abstract vertical. The reason is that it's actually quite simple to use. You always have a start method and also a stop method too. So over here, for example, okay, so the reason why we want to do that is because it's very easy if you are, especially if you're talking about you want to containerize it and put it on the cloud. So, okay, so over here, you can see Vert.x. I'll just, set your timer in here. And basically, that's how you do it. And every time too, you want to start an HTTP server listener. So you can kind of use the composite way of doing things, or chaining your call. So then you can basically do a create HTTP server and listen on the port and binds it there like that. So it's quite simple. And in order to start it in your main, all you need to do is Vert.x, start your instance and deploy the vertical. And that's how you do it. Okay, and quick thing. Right now I see that I'm running out of time, but I want to invite you to sign up for the IBM Cloud. And over here, I would not have time now, but you also see once you sign up, then you basically too want to suggest you to do also is be able to deploy this your Knative, I should say your Vert.x microservice. You can easily deploy it to the IBM Kubernetes service or into Red Hat the OpenShift too. So, but I guess for now I probably won't have time. I see that I'm kind of running short on time. So I would pass this on to Grace.
Mary, do you want to keep going? I think we have a few minutes left if you want to show the demo.
Oh, okay. All right. So I was just kind of quickly show, but I don't think I would have time, but I was just going to quickly show too. For example, I was actually, okay, so if you join me on the Twitch, I will show you more. But over here too, I have on IBM Cloud, you can make use of, this is an IBM Kubernetes service in here. And so you can actually define the nodes, and basically for running Knative. Knative, by the way, too, is basically it builds on top of Kubernetes, and it helps with like serverless and microservices deployment. And again, I just, actually, the thing is, let me show it to you. So if you go into your Kubernetes, assuming you do all these steps, which we will provide to you, you can look that up as well, and you can find me on Twitter and stuff. I will be happy to work with you on that. So go to your Kubernetes dashboard. It will actually, it's pretty nice. This one over here, it actually shows you how you can like step through and set up your Knative component. Knative essentially has two components. It is very new too, so I have to say it may take some time to get used to it. You can do serving, so it helps you to deploy it to Kubernetes. And then there's also Knative eventing. So that's the interesting part. It hasn't been quite a lot of, kind of source example yet, but that's something I'm intending to work on, is basically write up or kind of find out how to get a plugin of Vert.x into it, and then we can actually leverage on the Knative eventing to kind of handle the events in your Kubernetes cluster too. But okay, so now it looks like that my Kubernetes isn't coming up. So, and I apologize for that. But I think then essentially that's pretty much it. And we will have resources towards the end of our slides here that you can sign up for the IBM Cloud, and then we can also then have Grace take over on this part, and she's going to introduce you some microprofile reactive labs. So.
Absolutely. So as Mary mentioned, if you want to go and check out the repo where Mary's done this project, then take a look at the resources links at the end, or reach out to Mary on Twitter. If you want to get hands-on with some of this reactive technology and some of these reactive APIs, then you can also check out our interactive labs via the link here. And there's 4 modules at the moment, but we are adding to them all the time, introducing you to things like the reactive messaging specification that Mary mentioned from Microprofile, as well as things like how to test your reactive application using projects like microshed testing, how to enable asynchronous calls, and all of that good stuff. So if you'd like to have a look at that and get hands-on with some of these reactive APIs that we've mentioned, then this is a great place to start out. So as Mary mentioned, we have some useful resources for you to go and read after this presentation. So if you'd like to have sort of a concise guide to reactive systems, this ebook is only about 30 pages long, so it shouldn't take you too long to read. And it is an O'Reilly ebook, so you guys should all have access to this. It is free online, so go and check that out. This will cover sort of what reactive systems are, why you'd want to use them, and use cases for them, and how to go about designing and building them. And then here at the end, we have some further links. So if you want to catch Mary and I on Twitter to ask us any further questions, our Twitter handles are there. Feel free to reach out to us. And then we've got some really useful reactive resources listed down here on the side, some to IBM developer articles that Mary and I have written, others to external resources like the Cognitive Class AI course, which is sort of an introduction to reactive architecture course that you can get a certification in, and also things like reactive design patterns that we mentioned to go further into detail in that section. And then on the right-hand side here, we basically listed out all the links you'll need if you want to check out any of the reactive frameworks and toolkits that Mary ran through for us.
So thank you. Yeah, so here are some of the IBM resources. If you like to, please sign up for our IBM Cloud, and that's the QR code for your quick connection to that. So.
Thank you both so much. I was a moment delayed because my dog was freaking out. So, first of all, I want to say thank you so much. There's just, I mean, this was like a whirlwind. There's so much to talk about. So I'm actually so glad to hear that you're on Twitch, which is super cool. And we have all of these resources. I'm going to ask you 2 questions, but before I do that, what I want to do is put up, we have an opportunity for the people that are here to opt in and receive more information from IBM. So I have that up right now. All you have to do is check the box, and IBM will be in touch with more stuff. And you can see they have it on reactive systems and reactive programming. So I'm going to leave this up actually while I ask a couple of questions. So we have a few questions. We're a little over time, but I just find this fascinating. So first of all, what I want to know is, this seems like it would be a good fit for so many industries and applications that are happening now, this sort of like reactive programming and systems. Can you give just like an example or 2 of where you're seeing this make all the difference?
Sure. I think I'd like to point out maybe one example. For example, actually, I did a talk with the RSocket engineer, lead engineer, Oleg, too. We actually work on a sample of using reactive streams for training a machine learning bot to play Pac-Man. So that's kind of a new area that we're trying on, and we're making use of RSocket to do that, and it's really, really fast. Yeah, so yeah, because then we want to have data coming in real time, and that's the advantage it brings in, is that is basically this real-time data that comes in and you process it as it comes. So, and well, the thing is, the specific case is that we're doing a case of Pac-Man, multi-user, multi-Pac-Man game. So that kind of scenario is real good because it handles all of these simultaneous streams coming into your processor to handle it in a very highly efficient manner. So that would be one thing.
Interesting.
Yeah.
Okay.
And also like IoT application too. So
yeah, that's what I was thinking. Yeah. So there's plenty of that.
I'm sorry, I spoke a little ahead of you. Please.
No, don't worry about it. You answered it really well.
Oh, thank you. I get too excited.
So okay, so two more questions. The first one is, if a microservice is reactive at UI, it needs to also be, so they're saying if a microservice is reactive at the UI, does it also need to be at the middle layer and the database? Do these need to support a reactive connection?
Yes.
Mary, I think this question's for you. Yeah, it has your name on it.
Oh, would you like me to? Okay, I'll answer. Yes. So I guess strictly speaking, the whole stack is supposed to be all reactive. But as such, you point out real good in which like database. There's actually no true relational database that's reactive, meaning that they are still using blocking I/O. So that's not really truly reactive in that sense. However, for example, like Pivotal, they actually have a R2 DBC, and that's a reactive database connectivity library. That's kind of close to being reactive in terms of the database connectivity. So I think too is that if you make use of like NoSQL and maybe GraphQL and all those, they will be like more effective in terms of if you think of it more like a whole stack being reactive. I think, yeah. So.
Okay. I think it's up to the user. I think the nice thing about reactive is you don't have to implement it at every level, but you can gain benefits from implementing it at each level individually as well as a whole.
That's right.
That makes sense. Yeah, I think that was the question too, right? Like, is it possible? Do you have to? So it's good that it's an option to know that. Okay, so final question. This is communication via messages means we decouple components, but also introduce eventually consistency into our system. How do you deal if some of your systems need strong consistency?
Yeah, so this is all to do with the CAP theorem, right? So consistency versus availability, and this is a design choice that you have to make for each application. It completely depends on what your application needs above others. And you're right, by introducing this high availability, you do have to compromise a bit on the eventual consistency. But for most applications, this is probably as close to reality as we're going to get. We live in an eventually consistent world. There are facts that you might know that I haven't caught up with yet. And that sort of mirrors the way that we interact as people and the way that we live our lives. So for a lot of applications, it actually works and is okay. If you need strong consistency, that's when you have to start thinking about, do I go with a relational database like Mary was mentioning and have that blocking I/O so that, my data is always up to date and it's always consistent, but I have a slightly less responsive system, but maybe I can introduce reactive systems principles in another part of the application.
Cool. So that's awesome. I want to thank you both. I think you're both available if people want to reach out to you on the Twitters and such.
Yes.
We know Mary's on Twitch, which again, I think is super awesome. So that's wonderful. Thank you. Everyone at IBM I've worked with is just a star. So thank you. This is obviously you're included in that. So, okay.
Thanks for
so
having
with
us.
that,
thank you.
Yeah, of course.